Hi students, in last class we discussed about dispersion of the light. Now we will continue that class. In this class we will discuss about scattering of the light, why sky appeared in blue color and why sun appeared in red during sunrise and sunset. We will discuss. Before going to scattering of the light, first of all we will revise Tyndall effect, which we learned in previous class. Tyndall effect. What is meant by Tyndall effect? When a beam of light passes through a colloidal solution, the path of the light becomes visible due to the scattering of the light by colloidal particles. This is known as Tyndall effect. When a beam of light is passed through colloidal solution, here we can see colloidal solution is present in the test tube. When a beam of light is passed through colloidal solution, the path of the light is visible inside the colloidal solution. This is due to scattering of light by colloidal particles. This effect is known as Tyndall effect. Here also we can see the path of the light inside the colloidal solution. And also when sun rays falls on a thick forest, we can see the path of the light. All these are the example for Tyndall effect. Tyndall effect is mainly due to the scattering of the light by colloidal particles. Now we will discuss what is scattering, how the scattering takes place. The Earth atmosphere contains air molecules, water droplets, dust, smoke. When sunlight passes through atmosphere, the path of the light becomes visible due to scattering of the light. We know that air molecule, water droplet, dust, smoke, all these are present in Earth atmosphere. Due to this, the path of the light is visible due to scattering of the light. The effect of the light on a molecule or atom depends on the size of the atom or molecule. When light falls on a atom or molecule, the effect of the light on a molecule or atom depends on size of the atom or molecule. If the size of the particle, the size of the atom or molecule is small, it will affected by higher frequency of the light or lower wavelength of light. If the size of the atom is small, it is affected by lower wavelength of the light, and vice versa. If the size of the atom is large, it is affected by larger wavelength of the light and smaller frequency of the light. If the size of the particle is small, it is affected by lower wavelength of the light, nothing but violet, indigo, blue. And if it is size of the atom is large, it is affected by higher wavelength of the light, nothing but orange, red color light. Now we will discuss scattering of the light. This is very important. This question is given in public examination March 2019. When light of certain frequency falls on that atom or molecule, this atom or molecule respond to the light whenever size of the molecule is comparable to wavelength of the light. Already we discussed, if the size of the atom or molecule is small, it is affected by the smaller wavelength of the light. If it is large, it is affected by the larger wavelength of the light. When light of certain frequency falls on the atom or molecule, this atom or molecule respond to the light whenever size of atom or molecule is comparable to wavelength of the light. The atom absorb the light and vibrate. When light falls on the atom or molecule which having corresponding wavelength, then the atom will absorb the light and vibrates. When it is vibrating, what happens? It will re-emit the light. Due to this vibration, the atom re-emit the certain fraction of the absorbed energy. Remember, initially the atom absorb the light when size of atom is comparable to wavelength of the light. Then it undergo vibration, it will vibrates. After, again it will emit certain fraction of the absorbed energy in all direction with different intensities. The re-emitted light is called scattering light, and the process of re-emission of light in all direction with different intensity is called scattering of the light. What is meant by scattering of the light? The process of re-emission of the light in all directions with different intensity is called scattering of the light. The atom or molecule is called scattering center. Where scattering takes place, that atom is called scattering center. The intensity of the light is the energy of the light passing through a unit area of plane taken normal to the direction of propagation of the light in 1 second. This is the definition for intensity of the light. When light passes through a unit area plane, the plane is normal to the direction of propagation of the light. Then light energy passing through a plane in 1 second is called intensity of the light. The angle between incident ray and a direction in which the intensity of scattering light is observed, we call this angle as angle of scattering. The angle between incident light and scatter light is called angle of scattering. And here remember, it is experimentally observed that the intensity of the scatter light varies with the angle of scattering. The intensity of the scatter light varies with the angle of scattering. If the angle of scattering is 90 degrees, the intensity of the scattering light is maximum. When angle is 90 degrees, the intensity is maximum. That's why this is the reason for the appearance of clear blue color when look at the sky in a direction perpendicular to the direction of sun rays. When we see the sky in a direction perpendicular to the direction of sun rays, then sky appeared in blue color, because at this situation it forms 90 degrees angle and the intensity of the light is maximum. That's why it appeared in clear blue color. If our angle of view is changed, the intensity of the blue color also changes. If angle of our view is changed, intensity of the blue color will changes. Explain briefly the reason for the blue color of the sky. This is very important. This question is given in public examination March 2015. What is the reason for the blue color of the sky? Our atmosphere mainly contains nitrogen and oxygen molecule. Already you know, our atmosphere mainly contains nitrogen. Nitrogen is present up to 78% in the atmosphere, in the air, and oxygen contain up to 21%. The size of these molecules are comparable to wavelength of blue light. The size of the nitrogen and oxygen is comparable to wavelength of blue light. So they scatter blue color, hence sky appear in blue. They will scatter blue color and sky appear in blue. Here we can see sky appearing in blue color. If the earth had no atmosphere, there would not be any scattering of the light and the sky would appear in dark. The sky appear dark at very high altitudes. At very high altitudes there is no atmosphere. That's why sky appeared in dark color. Why does sky sometimes appear white color? Why does sky sometimes appear in white? On a hot day, due to rise in temperature, water vapors enter into atmosphere. Water vapor will enter into atmosphere. Due to rise in temperature, water on the water surfaces will undergo evaporation and water vapor enter into atmosphere. This leads to abundant presence of the water molecule in the atmosphere. The amount of the water vapor will increase in the atmosphere. These water molecules scatter the colors of the other frequencies other than blue. So all such colors of the other frequencies reach our eye and sky appeared in white color. Due to presence of water vapor, sky appeared in white color. Why does sun appear red color during sunrise and sunset? This is also very important. This question is given in public examination June 2018. Why does sun appear red color during sunrise and sunset? At sunrise and sunset, the sun is near the horizon. During sunrise and sunset, the sun is near the horizon and light from the sun travels through the thicker layers of the atmosphere and longer distance through the atmosphere. Here, light from the sun has to travel longer distance through the thicker layers of the sun. That's why in morning and evening time, during sunrise and sunset, except red light, all colors scatter more. Already we discussed, among all the colors, violet having highest scattering and red having least scattering. So except red light, all colors scatter more and vanish before reaches our eye. Here sunlight has to travel longer distance during sunrise and sunset. So all the colors undergo scattering and they will vanish before they reaches our eye. Since scattering of the red light is very small, it reaches our eye without any scattering. So as a result, sun appear red in color during sunrise and sunset. Here we can see sun is appear in red color. Here we can observe the earth surface. It is surrounded by the atmosphere. This is the atmosphere, and during morning time, sun is at horizon. Here we can see sun is near the horizon. When sun is at horizon, sunlight has to travel longer distance. So before reaching the earth, all the colors of the light undergo scattering and they will vanish before reaches the earth or before reaches the observers. Only red light without any scattering, directly it will reaches the observer. That's why sun appear in red color. Here during afternoon time, sunlight has to travel least distance. So that's why it appear in white color. All those colors undergo scattering and they will reach as the observer. That's why it appear in white color. During evening time also, sun is at horizon and sunlight has to travel longer distance. That's why all the colors undergo scattering and they will vanish before reaches the observer. Only red color without any scattering, it will reaches the observer. That's why sun appear in red color during sunrise and sunset. Describe an experiment of scattering of light. This is very important. This question is given in public examination March 2018. What are the required materials? Beaker, sodium thiosulfate, sulfuric acid, water. These are the required materials. Now we will see procedure. Take a solution of hypo. Hypo chemical formula is Na2S2O3 5H2O, sodium thiosulfate and 5 water molecules. That is a hypo solution. Take a solution of hypo and with sulfuric acid in glass beaker. Add this hypo solution to the sulfuric acid taken in a glass beaker. Watch the formation of grains of sulfur. When hypo react with sulfuric acid, we will observe watch the formation of grains of the sulfur. Place the beaker in which reaction is taking place in an open place. Place this beaker under the sunlight. This reaction takes place in sunlight. Observe the changes in the beaker. You will notice that sulfur precipitate as the reaction is in progress. As the reaction is in progress, you will observe that sulfur will precipitate. At the beginning, the grains of the sulfur are smaller. As the reaction is in progress, their size increases due to precipitation. At the beginning, sulfur precipitates. Grains of the sulfur are smaller. Sulfur grains appear blue in color at the beginning. When they are smaller in size, they appear in blue color. And slowly their color becomes to white as the size increases. As their size increases, they appear in white color. This is the reason. The reason for this is scattering of the light. This is due to scattering of the light. When the size of the sulfur grains is small, it is affected by smaller wavelength of the light, that is blue color light. That's why they appear in blue color. and when their size increases, and they will scatter other colors of the light also, and they will appear in white color. Here we can see blue color sulfur grains. At the beginning the size of the grains is small. It is almost comparable to wavelength of the blue light, hence they appear in blue in the beginning. So at the beginning size of the grains is very small. It is comparable to wavelength of blue light. That's why they appear in blue color. As the size of the grains increases, their size becomes comparable to wavelength of the other colors. That's why as a result of this, they act as a scattering center for other colors, and the combination of all these colors appear as white. Combination of all these colors appear as white. Here we can see sulfur slowly changing into white color. Now we will discuss about Sir C.V. Raman. He is the Indian scientist who got first Nobel Prize in Science from India. Sir Chandrasekhara Venkata Raman, our beloved scientist and Nobel Prize winner. Sir Chandrasekhara Venkata Raman. He was born on November 7, 1888 in Tiruchirappalli. It is near to Bengaluru. He explained the phenomena of light scattering in gases and liquids. He explained the phenomena of light scattering in gases and liquids. He found experimentally that the frequency of scattered light by the liquids is greater than the frequency of incident light. Here we can understand, during scattering, frequency of the light is changing. Frequency of scattered light by the liquid is greater than the frequency of the incident light. This is called Raman effect. By using this Raman effect, scientists can determine the shape of the molecule. He discovered Raman effect on February 28. So, our Indian people, we will celebrate February 28 as National Science Day. Remember, this is about Sir C.V. Raman. He is the first Indian scientist who got Nobel Prize in Physics from India. He discovered Raman effect on February 28. That's why we will celebrate February 28 as National Science Day. Now we will discuss the reason for the twinkling of the stars. This question is given in public examination March 2015. Actually, this question is based on 9th class syllabus. What is the reason for twinkling of the stars? The continuously changing atmosphere. We know that from earth to surface to higher altitudes, temperature will slowly decreases. Due to slowly decreasing in temperature, density of the air increases. From earth to surface to higher altitudes, temperature decreases and density of the air increases. That's why different densities of the air having different refractive index and refract the light from the stars by varying amounts in different direction from one moment to other moment. The light from these stars has to travel different densities of the air. That's why the light from the stars undergo refraction varying amounts and in different direction from one moment to next moment. Here we can see, that's why the stars appear twinkling. Due to change in apparent position of the stars to the observer on the earth, stars appear twinkling. Here actual position of the star is different, but due to refraction there is a change in apparent position of the stars. Due to change in apparent position of the star, one moment to the next, they appear twinkling. Students, all of you make notes, prepare well. We will continue in next class. This lesson is completed. In next class we will discuss another lesson.